Okay, folks, welcome to Arendelle, a show where we try to learn how to build a modern distributed database. And when I say modern, I actually do mean like database from science fiction. Database written in crazy language, which doesn't do full memory safety like Rust in 21st century. Database which avoids using malloc and free, and the topic of today's and yesterday's and a couple of future episodes, database which has crazy upgrade procedure. Okay, so let's jump right in. Okay, the upgrades. The problem which we are solving is that the shortcuts on this operating system continue to not work properly. Okay, the problem that we are solving is that upgrades are generally hard, and that when you upgrade software, ideally you want to change implementation detail while maintaining the interface. This is challenging for Tagabidal because for us, our implementation details are part of our interface. Specifically, Tagabidal is a distributed database. That means that the data is replicated across six different machines, and each of those machines eventually stores the same data. But the data is the same not only logically, but also physically. This is related to Tagabidal repair and state sync protocol. So we want the data to be physically the same. And that creates a problem that when we do an upgrade, we might change how the data physically is represented. And that might break the invariant that all the nodes in the cluster have the same physical data, because if one node is upgraded, it now has different data on disk. So how do we solve this problem? We solve this problem by essentially concatenating several versions of Tagabidal into a single binary. And that binary version, this wide binary can then, quote, quote, dynamically dispatch to a specific version of Tagabidal to process each specific operation. So we have, in our algorithm, special code which tags each operation which is processed by Tagabidal with a version which should be processing this operation. And we have a little bit of dynamic dispatch in our binary, which says, hey, if I'm on version X and the next operation should be processed by version Y, and I have version Y in my binary, then I'm going to restart into version Y. Okay, so let's quickly, and today we are, so okay, this is kind of like, I jokingly showed this as a cat command, so we like literally concatenate binaries. This is slightly more involved. And today we are going to look into the build system, a set of things which manages to concatenate the files. But before that, let's actually kind of like show this in action. So I think we did this last time, but well, no harm in doing this more. Hey, look, my pull request is approved. Okay, let me quickly merge pull request. Okay, I love merging pull requests. Okay, where we were? Okay, yeah, we wanted to show this magical upgrade thing. Okay, let's go and download our latest release of Tagebeetle. Tagebeetle Mac. Okay. What? Pardon me? Okay, what is happening here? Okay, so like like debug version of Tagebeetle is somehow smaller than release version of Tagebeetle. This isn't right. This should be fixed. Okay, so I will remember that. But anyway, okay, I'm curious what. Okay, I'm going to download them both because I'm super curious. Okay, let's go to our send to main. Actually, maybe I should swap that to dark mode so that you are not blinded. Okay, I want to Tagebeetle. Okay, and Tagebeetle 2 and Tagebeetle. Okay, thank you for protecting me. Tagebeetle version, Tagebeetle 2 version. Okay, we agree on the version, and if which of them is debug. So this one is debug, and this one is really safe. Okay, and okay, so okay, when unpacked, it looks reasonable. So release safe is actually smaller one, but still, it's kind of crazy. Okay, so let's say that Tagebeetle is Tagebeetle 0.16.4. Let me check that this is indeed the case. Okay, not 4. Why it says 4? Okay, it's risk climbing. Okay, Tagebeetle 0.16.51. Okay, so 0.16.51, we are going to format cluster equals 0, replica count equals 1, replica equals 0, 0, 0 dot Tagebeetle. Replica I still can type. Okay, file exists, so let me kill this thing. Okay, yeah. And now we are going to build config. We are going to build a multi-version version of this binary. We are also building debug mode. Well, I think it's fine if it is debug. Okay. So zig out bean tagbidal. This is going to be tagbidal 0.1652. Let's see that it agrees with us that it is version 52. Okay, and now I'm going to start this thing. And we'll see that this opens the data file, notices that it is 1652, but the data file was created by 1651. So it restarts the previous version, which is bundled in this wide binary, opens the data file again, then notices that, okay, and now the release version and the version of the data file match. And as we are a cluster with only a single replica, we actually can upgrade. So we start the upgrade procedure and we finish the release procedure. So at this point, we actually stamp Superblock with the new version. And then we execute again, now the new version. Okay, so we reached unreachable code. Okay, folks. So I guess it is a change of plans because we are going to debug this panic. I wonder if it has to do with us do this upgrade without actually, like, with an empty data file. And like this trace is horrible. Okay, yeah, then it restarted all right. Okay. It really is pretty unfortunate to... Let's see if we can reproduce this. To give it all template. Okay, and then we say start. And will this crash at the same place? Hurrah, it crashes. Well, it is good news, because if it crashes, that means we can debug this. Take a little template. Okay, so let's restore from template. Now, I also want to double check that it isn't our port 0. Okay, we can't bind to port 0. So wondering, like, why version. Why are we not seeing backtrace? Because it is debug mode. Oh, it is because we kind of like do crazy thing here with like reexec and whatnot. But still. Haha, okay, so it okay, so this is specifically the interaction of upgrades and port 0. Okay, let's just double check this. It's a paired template, and then we start, and now we pass port 0, and we should crash here. Main port okay. What could go wrong here? So it's where are we crashing? Could we be crashing in the guts of some something? Okay, I'm actually curious whether LLDB would be able to help us here. So let's LLDB. Let's try LLDB because yeah, I'm usually like not using debuggers, but I mean if you have like stack trace is bad, then what is not a valid executable? Like how come it's not a valid executable? We just executed it and it was fine. Okay, actually, let me do this thing here quickly. How could I say this? HU tag middle. Well, no, I don't want to do this. Oh, it is valid executable, right? Yeah. And it's not a valid executable. Like what? Target create. Okay, do we have GDB here? No, we don't have GDB here. Okay, and this is why I don't use debuggers, because debuggers just don't work. Like really, like see, like if a problem is simple, I debug it with printfs. I see the stack trace, I just like debug it. Like I don't need debugger to solve a simple problem for me. I only need debugger to solve like a complex problem where we have like this like dynamically re-executing thingies with like a backtrace or something like seriously gone wrong here. I really need help of debugger here. And like debugger says, hey, this is not a valid executable. Like, I mean, like it is valid, like it executes. Well, at least until it crashes. Okay. So well, let's do bisection. Okay, so now, okay, I think I will need a makefile here. Okay, where is my makefile? It should be here. Yeah, this is my makefile. So I want to. So this is what I want to build. And okay, and this is why JavaScript is glorious, is that I actually could do this. So I want to build, and in parallel, I actually want to copy yep. I actually want to do this. And I wait for all, and then I do wait Zigout, beam, tiger, beetle, start. Okay, let's see if this works. So we are building. Can I also ask this set? Okay, it crashes. Okay, now I realize that I probably should explain what address 0 is. Okay, so did we cover this before? I'm not sure, but well, anyway. You see that I pass this address 0. I don't think that port 0 exists. I think in like the IP frame, if you specify port 0, it either is like completely invalid or means something like broadcast or whatever. I don't know, probably invalid. I mean, you could look up this on Wikipedia or like whatever. But the operating system API is set up in such a way that if you ask OS to bind port 0, it actually just finds any free port and binds it to this port. And that means that you could allocate any free port without specifying it. So you know, if basically I can run this twice, and I get 2 instances of TigerBeetle where each of the instances is bound to like some free port. If I specify like something like this, 1 to 3, 1 to 3, 1 to 3, 1 to 3, then okay, I can't specify 1 to 3, 1 to 3 because ports go to 65,000. If I do this, then if I run these 2 commands concurrently, they will conflict with port and they will crash. One of them will crash. If I specify this, they will not crash. And this is like super useful for tests. So we say that, okay, if the address is 0, then we like just ask operating system to give us a port, and then we print the port to standard output. So the caller could say, okay, we are listening on port such and such. You actually see that here we are printing our port number. Yeah, and another thing we have here is that we have this extra logic where we I don't think I even well, no, I think I need this. We have this extra logic where if the port 0 is specified, we exit a process if standard input is closed. Why is that? Again, this is also helpful for tests, because imagine a test which spawns your TigerBeetle binary, and then there is like a bug in the test, so test process exits without properly cleaning out the TigerBeetle binary. Well, we'll have like a leak in process, and that's not good. But the standard input for that process will be closed. So we use this closing signal as an indication that our parent has exited, and that it is time for us to exit as well. Okay, if we completely disable this logic, will it still crash? I don't know. We'll see. And I kind of like have a suspicion that it will crash because I think we already... Okay, it crashes. Okay, this is super curious. Could this be some like login issues for standard error? Well, that shouldn't be the problem. And now, okay, maybe I was wrong that it is port 0 issue. So let me also start it again with different port. Okay. So it really does have to do with close. Oh, I see. I see what is happening here. I think we tried to close standard output twice. So presumably, if I comment this out, then it will work. Let's see. Okay, what happened here? So this was a comment, right? And they asked my editor to comment this whole thing. Okay, maybe I didn't task this properly. Okay, so I think this is the close call, which is a problem. And again, like, well, okay. I was kind of like going to rant that, like, debugger wouldn't help us because the problematic call is closed, but it is not where the problem fails. But well, probably I would see in the debugger that we fail in the previous line and then realize, hey, actually this is port 0. Wait. It still fails. It still fails even without closing standard error. Okay, this is just fixing it. Like, okay, get standard output is like nothing, right? It's just like, yeah, like return 1. So this is like literally number 1. It still fails. So is it the right that fails? Okay, I'm mystified here. Honestly, this kind of like doesn't make sense. What is even happening here? Oh. I see. I see. This is hilarious. I see the back. Do you see the back? Like, you see? I mean, so I'm super puzzled because it kind of like really, it really does look like this closes a problem, right? And like, if I just comment it out, like, It shouldn't be a problem, right? But like, I mean, I committed it out, I rebuilt the code, and now it fails. So what is the problem? Well, you see, this is close call in the previous binary, because we have two binaries, two tag orbitals in process. And first, so we start new, and it doesn't do anything. And then we start the old one, and it prints the port. And then we start the new one, and this one, so this one closes. So like the way I realize it is that here I commented out the logic for printing at all, but the port is still printed because it's the old binary who prints it, and it's the old binary who closes the standard output. Okay, but what should we do here? Oh, we do like this. Close is important because okay, because we kind of like, we do want to signal to our core that, hey, we have bound the port, and this port should be available. Okay, so maybe we should do this. But actually, even if it is unreachable, it shouldn't be okay, I'm confused now. What if we flip those around? Will we steal and where is this multiversion binary? So I think we start multiversion somewhere very little, very early. So let's just or through here. Okay, so let's just remove the multiversion here and make this. So now we remove the multiversion. So we should immediately go to this code. And well, error union is ignored. No, I don't want to ignore error union. I actually want to cause an error here. So what bugs me? Here we have like reached unreachable code. But it shouldn't be unreachable code. It should be just like, hey, I tried and replica release execute unsupported. Release transition. Can we do this like before? Why am I not getting backtraces here? What did something broke in Zig 0.15? Zig 0.14? Reason open. Okay, I think. Oh, okay. This is too complicated. So let me just run this start address 0 tidy middle. Execute run. Okay, this is still tidy middle is still old one, I think. Okay, let me build run Path already exists. Okay, so many defenses in depth. Okay, okay, so this is curious. So maybe we still have a bug here, just in a different place. Oh, finally we have a stack trace. This is beautiful. So, oh dear. Yeah, this is kind of hard. So we correctly log an error there, but when we actually crash, if anything happens here, because like there is next tick stuff happening in the open, and there is like a bunch of next tick stuff happening in the open. Well, what should we even do here? Hmm. Okay, this gets curiouser and curiouser. Because, okay, so the crash is actually, I mean, the crash makes sense because if you start with port 0 and then you restart due to upgrade, well, there is no way you could, like, you'll bind a different port. So that just kind of like doesn't compute, doesn't make sense. Port 0 really doesn't support upgrades. Actually, okay, I think I know how to fix it. So if args address 0. Okay, let me args address 0 break now. Due to, how do we call this address 0? Zero. Okay. Disable to due to addresses 0. Okay. Okay, and I think if we do this now, well, this doesn't work. Address says 0. Okay, now this should work. Hi there. Okay, well, now we kind of like panic with like a risk unsupported, but that at least makes sense because upgrades disabled due to RS 0. Okay. Take a bit of disable upgrades with addresses 0. Um, with addresses 0, after we start, the replica would bind to a different port, which doesn't make sense. We could perhaps try to reuse the port between replica incarnations, but that doesn't seem worth the hassle. Note that what actually would happen is that a replica would get an error if you try to do upgrade with addresses 0 before this R, is that a replica would get an error in close. No, not replica. Out close in on a print call, because it is that the reincarnation of a replica because the first incarnation would have closed at there equal 0. The error by itself is fine, but it will cause replica init, which would then panic due to storage next tick still running. That is also a bug, but not the one I intend to fix here, because it is like it is already okay. So did we get a reasonable diff here? If address is 0, multi-version upgrade is disabled due to address is 0. Okay. Git switch -c matclat address is 0 prevents upgrades. And let's assign this to the mastermind behind this whole thing. Here we go. Okay. But at least we've learned about address 0 pattern, which I think is very good pattern. And like really, like if you build any kind of a server which only needs a single port, that you should implement this. You should allow specifying address 0, and you should do this self exit if standard input is closed. because it is super helpful for this. Anyway, and it removes the need to do any kind of like timeouts in your code. Okay, but that leaves me in a bind because we've spent like 40 minutes through the intro and slogging through this bug, and this leaves relatively little time for me to explain how we do the build process. Well, anyway, I think we can at least start because honestly, like there is a lot to the build process. So it will take more than one episode to explain it anyway. Okay. Build process. Let's take a look again at how we build this thing. So we say, hey, this is the version which we are building. And this is the version which we want to include. Let's open, no, not build.rs, build.zig and see how this all evolves. So somewhere at the beginning of our build process, we have top level steps. And then we have options. And yeah, this is the multi-version. So let's see. Where we pass in multi-version. And this is build title. Okay, multi-version. So what we do with this multi-version? Well, first of all, we go and download release, and I think this is I think this is something horrible. So okay, downloading release. Oh, actually, I can specify latest here. So actually, when building this thing, I didn't have to specify this. I could have said latest. I forgot about that. Although I now remember implementing that. But well, okay, useful to share for someone who remembers it. Okay, so we figure out like what we want to download. Oh, by the way, yeah, this supports cross compilation, so we could build multi-version for Linux, which is cool. Okay. Actually, I'm curious. I'm going to do something relatively stupid. Do we have wine? Okay, we don't have wine. Well, if we had wine, I would try to run like Windows version of Zig compiler because Zig 0.14 didn't work for wine, but maybe 0.15 works. But it all doesn't work. Okay, so we go and we ask to fetch this particular URL. I'm wondering, I guess latest will be cached. Anyway, and this is crazy. So how do you like download file during build in Zig? Well, you could use Zig fetch command, which supports the downloading. So you see, I want to download this URL. So I go and say, hey, please let me download. Let's run a Zig fetch URL. So actually, okay. URL equals options URL. Let's see. Okay, I'm still not a proficient Zig programmer because I forgot this thing. And okay, so we actually, why? Oh, okay. Why I'm trying to download this twice? This doesn't make sense for me. Oh, I think once it is for tests. Okay, so yeah, you run this command and it prints like some cryptic number. This cryptic number is, I think, okay. Okay, yeah. This cryptic number is just a path into Zig's cache directory. So yeah, that's it. And then, well, the problem is like, we need to return a lazy path. And I mean, do we actually need copy from hash here? Because I think we don't, actually. Actually, I think we don't. Oh, no. Because we might want to fetch it from, okay, do we fetch? Because we might want to check that the hash is correct. Yeah, well, anyway, this is probably more complicated than it needs to be, but basically the idea that this thing fetches us the path into like the global cache, but we want it to be in the local cache, and we also verify. We want to verify the hash. So we need some custom logic here, and the way you write custom steps in Zig build, like actually the most economic way, is just to like write a dedicated binary. And because this binary is small, I'm actually going and specifying the source code of this binary in line. So this is custom Zig step, which runs, it takes 2 command line arguments. Well, no, it takes 5 or 6 command line arguments. Checks the hash and copies file whether it should be. Okay. So this is fetch. So this is fetch. This was download release. So yeah. So we downloaded our release, and now we have this like magically tracked by the Zig build system lazy path, which will be populated when we have which will be populated like automatically and then cached. So we won't be downloading this file every time. It will be downloaded only once. Okay. Then, okay, we go to build executable multi-version. And we have, again, the same pattern. We want a custom script which kind of like takes one version of TigerBeetle, takes another version of TigerBeetle, and then like smudges them together like the cat utility, but with some more zest. And that is implemented in this like build multi-version. scripts, which probably we'll look at tomorrow. Okay. So we have this multi-version step. The way will be, oh yeah, and here I probably should explain a little bit about like why we aren't just concatenating binaries. And the reason for that is that we want to use ELF sections for binaries because ELF file format already has like, tables. And we want to pack several versions of TigerBeetle, so not just two, like 5 or 6 into the same binary. So we need to have like a little table which says, hey, this version has this, that version has that, and like ELF file already has this table, so we want to reuse it. So we want to use a tool for manipulating ELF files, and actually this probably is going to be part of Zeek at some point. Actually, okay. Obj copy. We have obj copy. Do we have? Yeah. So we have add section. We sadly do not yet have remove section. So we probably should. Okay. So like, okay, if someone wants to contribute something to upstream Zeek, then please implement Zeek obj copy or remove section. That will be like hugely helpful for us because then we'll get rid of this LLVM dependency. Actually, I mean, add section. Pull request. So, I just want to go and create this. I don't want this. Add section. There was obj copy support add section. So let's copy. So is it enhancement? Kind of like, okay. Support remove section. And actually, LLVM copy. Okay, so let's see if we downloaded we use obj copy in our build. So it should be okay. Help. I just want to see how many options. Okay, let's see. It doesn't support remove section. It doesn't support it would be useful for Agibito, at least if it also supported at the moment we use LLVM copy, which is fine. Copy for that. Let's begin with Zig would be Zap. Okay, and let me quickly check that there isn't such an issue already. Oops, copy. No, that's not it. See also okay. The issue created. Where we were? Oh, yeah, right. So that is like build multiversion is a custom step which uses LLVM OptCopy or hopefully in the future just Zeek OptCopy to cook this multiversion binary. So we go and we pass it to it. Current Tagibidal, past Tagibidal, debug, target. I'm actually not sure why we need target, but presumably we need target. Path to temporary directory, and that's it. So I guess, well, that might be a good time to stop. So we wanted to cover, like, the entire process of building a custom binary, but instead we found a bug in our multiversion and address 0 combination. So we fixed that, but we covered, like, the overall flow of the build without looking at the logic directly. And that is, we download multiversion binary from GitHub releases using Zig fetch command. We actually also download LLVM OptCopy also from GitHub releases, also using Zig fetch command. And then we run some custom step which gets as an arguments the new binary, the old binary, LLVM OptCopy, and then does this magical thing, which we'll learn about next week. Okay, so see you all next week at 5 p.m. UTC live on Twitch. Goodbye.